Welcome, Lighting Essential Concepts is the current course, and in this first chapter we're going to take a look at the very basics of lighting in the Unreal Engine. That means that we have to talk about the fact that there are four of light actors, common properties, light intensity units, and the basic concept of dynamic and static lighting, and therefore also light mobility. So the level we have for this is called Lighting Basics, found in lighting_rendering, essential concepts, start assets, and it's a level right here. If you don't see the folders, by the way, it's that little button there toggles the folder view in the content browser. Now the level is kind of difficult to see, it's entirely black because we're going to light it. If you go to unlit, it's still very difficult to see, but it's slightly easier to see what we're looking at. It's essentially a very small, very simple grey white boxed apartment. There is a TV here and a couple of couches, there's a big window here, there's a hallway that goes nowhere, and a small kitchen, but almost no detail in the kitchen at all. Outside we have a couple of trees, the sky, and a swimming pool. This is the environment we're going to use for everything we're going to cover about lighting and rendering. So the first thing we want to do here is place a very basic light, or very first light ever. We're going to switch back from unlit to lit, so otherwise we wouldn't be able to see the light. And then we're going to go inside the apartment, preferably. And in the panel on the left side, you can see I'm in the first tab, because you are actually able to switch tabs. But make sure you're in the first tab all the way on the left. And then go to the section called lights. And these are the four types of lights that we have. So Unreal has a directional light, a point light, a spotlight, and a skylight. And that's it. Technically, it is possible to have a material emit lighting as well, but that's not very commonly done, so we're not going to cover that in this chapter. But let's stick to a point light first. A point light is, as you expect, an omnilight or a point light. It emits light in every direction from its surface. You can also add a spotlight, so I've deleted that one, I'm adding a spotlight instead. A spotlight does what you expect it to be. It's a spotlight, you can rotate it, and so on, and that's that. A directional light is essentially the sunlight. If you add that, it doesn't matter where you add it. So the directional light and the skylight, both of those will affect the entire environment. It doesn't matter where you place them, they will affect everything. So I can place it inside and it still lights up everything on the outside as well. It causes a directional light to come from the direction of the arrow. So you can see you can obviously rotate this and have it go in a different direction. And then lastly you have a skylight, and a skylight is essentially ambient lighting. A skylight is more special than just applying a solid color to everything. So you can see that right now it's very simple ambient lighting, as in everything is simply lighting up. But later on we're going to learn, as we start changing the properties and all that, that this goes actually a lot further than simply applying an ambient tint to all of the models. What a skylight really does is it captures a cube map, an image, a 360-degree image from the sky and all distant geometry. So it takes a picture of this, and then it uses that cube map to project the lighting back onto the level using the colors that were captured in the cube map. So if you would have a sunset that is very orange on one side and very blue on the other side, the sky is very blue, then you would get blue ambient light coming in from the atmosphere on this side and orange light from that side. Either way, it's used for simulating the atmospheric scattering of the light from the sky. So we've gone through four types of light actors. Let's switch over to the common properties. Let's add a point light again, and let's use that to figure out, take a look at some of the properties we have. If you look in the details panel on the right side, you see we have intensity, light color, intensity units, and attenuation radius. Those are the most important ones to start out with. There's actually a lot more properties. In fact, you can press this little arrow and you would see even more properties, but let's ignore all of that for now. And let's only focus on what's really essential. Intensity does what the name implies. It is simply how bright the light is. So play around a little bit with the number, you'll see what it does. But you also have intensity units, which is set to candelas. If you change that, for example to unitless, it uses a different unit scale. The outcome is the same, but it's simply different values, different types of units. You can set it to lumens as well, same thing. It doesn't really matter which one you use, there is no impact on performance or anything like that. Essentially it's really just preference. So take the one you feel comfortable with and then just configure it as you wish. I'll switch back to candelas, which is the default one. And if you press a little yellow arrow pointing left, by the way, you can always reset the value to the default one, which is maybe a little bit bright here, so maybe that wasn't the best idea, but essentially find the value that works best for you. One thing I do want to point out is if you go to the viewport options here, the third button called Lit, it says exposure, use game settings. You could consider turning that off to essentially force the exposure to EV100. If you want to judge the lighting a little bit better without the exposure possibly altering the brightness of what you're looking at. Now beyond that you have attenuation radius, which also does as the name implies, it's simply the radius of the light. You can change it and you can see what happens. You can set the color, again speaks very much so for itself, it's simply the color of the light. Or alternatively, and again it's just preference, there is no impact on performance or anything else, it's purely preference, you can enable use temperature and then instead use a temperature setting here rather than a color. So the color is defined by the temperature as defined in this property. That works too. And then lastly I'd like to point out that it says cast shadows here, there's a checkbox. Again, as the name implies, it turns off shadows, but it's also a box called Affect World. If you turn that off, you essentially turn the light off. And in fact, there's a setting called Visible. If you turn that off, it does the exact same thing. So Affect World or Visible is essentially the same thing, and you can use that to temporarily disable a light while you're working or you're testing something and so on. Spotlights are very much so the same, by the way. If you look at the properties there, it's the same type of properties, but there's an inner cone angle and an outer cone angle, which is the most important difference here. And in terms of a directional light, if you add that one again, it doesn't have a radius, but it also has the intensity, light color, and that's essentially it. Simpler. Skylights is a bit different, but the most important one here too is light color. If you would want to change the color, you usually don't do that because it does capture the sky, so it's going to figure out the color by itself, but you do have intensity, which could be a good thing to change. And also technically, if you click on advanced options, there is a setting here that says lower hemisphere is solid color, and then the lower hemisphere has been set to a black color. That explains why the ceiling remains black. Usually this is what you want to have, because later on when we calculate the lighting, that should be fixed by the bouncing of the lighting, but every now and then you'd like to turn that off and actually capture the lighting from below the environment as well. For example, in a skyscraper, that's probably what you need to have. Now we're going to close off with a very brief section on dynamic and static lighting and light mobility in order to introduce the next chapter. One very important setting that we haven't talked about, I'm going to delete the skylight I placed in the previous section, place a point light again, and we can take a look at mobility, which isn't even in the section on lighting, it's actually in the section on transform. But this mobility setting, static, stationary or movable, is extremely important for lighting. You will have to understand this properly if you want to work with lighting in Unreal. And what it does exactly, that's something that we're going to cover in a later chapter. But very briefly mentioned and briefly touched on, it controls whether the light is baked into the environment or whether the light is rendered in real time. So static is baked, movable is real time, stationary is some kind of strange hybrid blend between both of them, because both of them have specific pros and cons. There's weaknesses and strengths with both of them, so stationary tries to blend both of them together to have a little bit of the best of both. So again, we're going to touch on this later on. But part of the lighting in Unreal is baked into the environment, part of it is real time. And it's the blend between those two systems that is going to be a little bit tricky to master in the beginning. But we'll dive deeper into that further in. So we've gone through the 4 types of light actors available. Common properties such as the intensity, we've talked about color a bit as well, the range and so on. And briefly touched on the importance of static and dynamic lighting and how the light mobility setting is altering whether a light is dynamic or static.